Thank you very much. I'm Gergely from Aimotive. It's an honor to have the opportunity to speak here. I have been asked to give you a presentation which is slightly technical, give specific information, not just generalities, and still can be followed by anyone who is interested. And we are not going to discuss deep technical details, but I really wanted to give you a topic which is simple but important enough to be presented. As mentioned, in ADAS and automated driving, distance estimation is really one of the basic, most important stuff. It's interesting because it's really simple in complexity, but it's very high. Its importance is very high. As mentioned, automation, automated driving has many purposes. There are no such things as self-driving car. There are many different use cases, many different operation domains, many different requirements, safety levels. And all these kind of different solutions and business use cases using different sensor setup, different operation conditions, etc. What I want to say with this is there is no single golden solution. No, not for perception, not for decision making, and not for distance estimation. What I'm going to present now to you is a kind of toolkit that anyone can use to build up a distance estimation method suitable and safe enough, precise and robust enough for a specific use case. ADAS and AD shares a lot of common development philosophy, but they are also fundamentally different. Just give you an example. For example, in ADAS, if you have an ACC function, an ACC function guarantees that the car won't brake if there is nothing in front of the car. If there is empty space in front of the car, then the car should not brake, because otherwise the driving experience would be very bad. But an ADAS function, an ADAS ACC function, does not guarantee that the car will always brake. That's a very, very, very big difference compared to automated driving. In automated driving, you have to guarantee at an ACLD level to see objects and to guarantee an ACLD level to see the empty space, so not to brake when there is nothing in front of you. A distance estimation method, it's not only characterized by its precision, but of course its costs, its computational cost, its robustness, its operation domain usability. So it's really a multidimensional problem and must be designed along in the knowledge of the complete system. So we cannot really speak about separately. And the whole purpose of automation is really to replace the human and not to replicate it. Sometimes there are discussions, interesting discussions that, and interesting developments that try to mimic the human behavior and try to copy, to replicate the human behavior, which is, at one part, is very interesting because we can learn definitely a lot from human behavior and human driving. On the other side, it's really dangerous because if we copy too much human, we will do the same mistakes. So in my view, the purpose of automation is really to replace the human, not to replicate it, and we need to have superhuman capabilities in all sense for perception, for motion planning, decision making, and for control. And this requires really multimodal, multi-channel observation of the environment.